Welcome to lesson 75. It's all about area of irregular polygons and composite figures. These are not shapes that have very simple area formula, so we're going to have to do some magic in this lesson. So here are the things I want you to watch for as I work. Watch how I decompose polygons into triangles and quadrilaterals, because we know how to find the area of those two. Then watch how I accurately and consistently calculate the area of those triangles and quadrilaterals. So if I can find the area of the pieces, I can figure out the whole piece. And how I can find the total area of an irregular polygon using sound strategies. And you're going to see two today. I'm going to use a decomposition, and then I'm going to use one with negative space. So get some practice in. You're going to do the exact same thing to show you can find the area of any irregular polygon. I love finding area of irregular polygons. We're going to look at two possible strategies today: decomposing and finding the missing piece from a bigger quadrilateral. So let's start with this first one. I'm going to try decomposing, and what that means is I'm going to try and cut it into a few pieces that are just regular quadrilaterals or triangles, because I know how to find area of quadrilaterals or triangles. So for example, I'm going to cut it right here, and if I were to cut it there, I have two rectangles, and I can find the area for these two rectangles using these dimensions: 3 by 4 for this big one, and 2 by 1 for this little one. So here's how I would write it down. All I'm doing is finding the area of figure 1 and adding the area of figure 2. And you try not to have more than 3 pieces, otherwise it just becomes really redundant. So area of my first figure is 3 times 4 plus my little figure 2 times 1. So area is equal to 12 plus 2. My area is equal to 14 square units. So that's the first method you can use. Hit pause just so you can see this one. And I will tell you again, you could have cut it if you wanted to here. You're still going to get the same area. You would find the area then of this rectangle, and they would still add up to 14. Let's try another strategy. In this one, I want you to find the missing piece. So watch what I do here. This one's cool. I'm going to make a big rectangle and find that area. So I find the area of the large figure, and I subtract the area of the small one. And the small figure is just an empty space, the negative space. So look what I do. So my large figure has the dimensions 4 by 4. And now I just have to find the area of this little part, this empty space. That's what I want, the small empty space. And that one is just a 2 by 1. So 16 minus 2, and I still get 14. So either one works. Here my area is 14, here my area is 14. You can use either method for finding the area of an irregular polygon. What you're going to look for are rectangles and triangles to find the area. So hit pause so you can jot this down into your notes, and we'll do another example. Okay, I have another irregular polygon here. I'm going to do the first method, decomposition. So I'm going to I'm just going to cut it this way. And so my big rectangle on the left has dimensions 12 times 30. Now, why am I using 12 and not 32? Well, because I only went from here to here. And I can use the opposite side to tell me that is 12. How about this one here? do I use a 32 or do I use a 17? Well, I only want from here to here, so that's easy, that's 20. And from here to here, that's 17. So my dimensions here are 20 times 17. So area is equal to 12 times 30 plus 20 times 17. So let's simplify these. My first one is 360. And my second one, 17 times 20 is 340. And when you add those together, you're going to get 700. But I'll double check my work. I don't want to make careless mistakes. So 700 meters squared. Hit pause and jot this down. And let's say you wanted to do the second method. Okay. So you would draw, here's your larger rectangle. Okay, and I would use my biggest dimensions. In this case, from here to here, I would use 30. And from here to here, I can either use 12 plus 20 or I can just use the 32. Okay, so area is equal to 30 times 32. In this case, minus, because I want this negative space, I'm going to take this part out over here. So I know from here to here is 20. What is this piece over here? Okay, use your opposites. I know that from here to here is 30 and here to here is 17. So what would this little piece be? So 17 plus what would make 30? 13. So do you see how I did that? To find this missing piece, I know that this is 30 and I know from here to here is 17, so I would need 13 more to make 30. So minus 20 times 13. That's this little piece here. 20 times 13. That's the area. All right. 30 times 32 is equal to 960 minus 13 times 20, which is 260. And when you subtract those, you also get 700 meters squared. So my area is the same. Hit pause so you can jot this down into your notes. And for our last one, you can clearly see angles that would make a triangle. So which would you rather do? Would you rather make a big rectangle and find the area of this little piece? Or would you rather cut this and find the area of these three pieces? I think the easier path would be to find a big rectangle and just subtract this little area. It has less steps, so I'm less likely to make mistakes. So my area of the big figure is 6 times 8. Minus, let's find the area of that little triangle. So my base would be 2. What would be, this part is 2, so what would be the height? I know from here to here is 6, and from here to here is 2, so this part has to be 4. So 1/2 times 2 times 4. All right, 6 times 8 is 48. And I have to minus the other part, so I already know C is not it. And I know it's going to be less than 48, so D would not be it either. So 1/2 times 8. 1/2 times 8 is 4. 48 minus 4 is 44. So area is equal to 44 inches squared. So here it is. That is my answer. Hit pause so you can jot this down into your notes.